Hello and welcome. My name is Professor Alex Cann from the University of Liverpool, and I'm giving you a short presentation about the first theme, the Enabling Technologies theme for the UKRI Interdisciplinary Centre for the Circular Chemical Economy. The hope is by the end of this presentation you'll have a little bit of information about what we're working on and our particular expertise and our core research partners, and it will also spark some interest on how and why you may want to interact with our theme and to help to develop new enabling technologies for the circular chemical economy. So the overall concept of the centre is to enable the transformation of waste into useful feedstocks and products which are produced currently by conventional linear routes in the chemicals industry. In particular, we're interested in seeing if we can develop pathways for the sustainable production of olefins, so the circular production of olefins. We're looking at doing this via a number of different routes. So we're looking at taking waste of various different forms and using different routes to transform this. I'll go through in a bit more detail on the following slides on these different routes, but very briefly it's to take carbon dioxide, so a waste product from many industries and many potential producers might be interested in this technology, and valorizing this carbon dioxide and making it into, for example, ethylene via electrochemical methods. We're also looking at taking wastes such as biomass wastes, leftover residues from food or biofuel production, for example, and trying to transform and to gain some value back out of these to make feedstocks for ethylene production eventually and more widely for the chemicals industry. The final area we're looking at is to take another waste stream, which is polymer wastes, and to look to see if we can chemically convert these, essentially depolymerize these back into useful intermediates and derivatives, again for feeding back into a circular chemical economy. So any producers of these particular waste streams or any users of the products for this may have an interest in our activities. The first area that I suggested was the electrochemical reduction of carbon dioxide. And this is a concept you may not be familiar with, but essentially we take clean electricity and we combine this in a reactor with carbon dioxide and water, a CO2 electrolyzer, and we can make a whole range of different carbon-based products. So we're pushing the carbon dioxide back uphill to higher energy products. And in particular, we're interested in making ethylene. Apologies for this rather appalling diagram. That is not the structure of ethylene, as I hope you'll know. And ethylene can be produced at scale. There's a massive market, and in particular the UK is a leading producer of ethylene. So can we make this in a circular way from carbon dioxide as our starting material? At the moment, these CO2 electrolyzers are very much at the concept and lab scale. So our project is looking at seeing if we can develop two new pathways to making these. One, a CO2 electrolyzer that goes directly through in a single device through to our ethylene, and one where we're going to make synthesis gas in a CO2 electrolyzer, so carbon monoxide and hydrogen, and look to feed this into existing technologies to try and make our lower olefins. So our expertise is in the catalyst itself and in making the electrochemical reactors, and our programs of activity involve scaling up these devices to test their feasibility, in particular under real-world conditions. So there's fantastic opportunities for partners to come in and to look to see if their particular gas flue streams or their waste streams are going to be of interest or applicable to this exciting technology. We're also developing new catalysts, and we're working to develop and improve existing catalysts as well to try and improve the overall efficiency of the area. So of course, partners interested in catalysts themselves or in trying to target specific products, maybe beyond ethylene, are most welcome. Alongside our electrochemical activities, we've got a program led by the University of Loughborough on the thermochemical and biological transformation of bio-wastes. And there's many different pathways to doing this, and this project is really about determining the best conversion pathways for different feed compositions. So there's a fantastic opportunity here for different bio-waste producers to interact with us and to look at the best pathways for their feeds. The activities that we're looking at as a team involve looking at different waste residues such as refuse-derived fuels, waste residue from municipal waste processing, and then to see how we can do co-liquefaction and how we can maximise the yields of the different chemical products in the aqueous phase and the bio-oil compositions, and how we can upgrade these into useful products. The final area that we're working on is on the transformation of polymer wastes, in particular polyethylene, back into shorter chain liquid hydrocarbons. And here we make use of the expertise in catalysis at the University of Liverpool and at Cardiff University, and we're looking at both a fundamental program in designing new catalysts using theory and a catalyst development and synthesis program at the University of Liverpool, making use of our world-leading high throughput capabilities at the Materials Innovation Factory. And this is a fantastic opportunity for those interested in trying to develop sustainable pathways for their liquid hydrocarbons and to look at the feasibility of this early stage technology for their area. As I say, we'll be looking at both modelling and actual real-world catalyst development. And this is really one of the most exciting areas currently in the centre. So that was a very short whistle-stop tour of our programme of activities. So in summary, I hope you can see we're working on a wide number of different pathways, and we're not claiming these are the only pathways to make circular chemical products, but we believe these are particularly exciting ones. We have expertise across a wide area of different technologies and approaches. We think this is a fantastic opportunity for people to look and work with us to see if they can valorize or utilize their waste stream. And that waste stream can be quite diverse, so we're looking at those ranging from carbon dioxide in flue gas mixtures through to biomass materials, which might be wastes, and to see how we can try and recover useful feedstocks from these. I encourage you to interact with us, and if any of this looks of interest, to make contact with us, in particular via our website, which is circular-chemical.org, or to email us directly. Thank you, and I look forward to hearing from you.